Good afternoon. Hope you are all back. The session 3 will be handled by Dr. S. Satish, who is going to handle the topic titled Hadoop Architecture, HDFS, and MapReduce. Here are some information about our session speaker. Dr. S. Sadish is a senior professor in Computer Science and Engineering Department, Vellala College of Engineering and Technology. He has an experience of 10 years in computer science and engineering and having well knowledge in data analytics. He has conducted many workshops in reputed colleges. He published more than 13 international journals and also published 4 books. Now, the session will be taken over by Dr. Satish sir.
Satish sir?
Ma'am, is it audible, ma'am?
Yeah,
Thank
yes.
you, ma'am.
Thank you, sir.
Ma'am, screen visible, ma'am?
Yes, sir.
Okay. Okay, thank you, ma'am. Okay, good afternoon, everyone. First of all, I thank HOD IT, Dr. V.K. Manoharan Sundaram, sir, and coordinators Nitya, ma'am, and Mageshwari, ma'am, for giving me an opportunity for this AICTE sponsor STTP on deep learning application and challenges in big data analytics series 2. Okay. Today, I'm going to cover a topic on Hadoop architecture, Hadoop distributed file system, and MapReduce. Okay. Ma'am, shall we start? Ma'am, shall I proceed? Okay. First of all, why Hadoop? Okay, why we go for Hadoop and what is Hadoop? Okay, today big data plays a major and vital role. Most of enterprises are beginning to realize that there is huge volume of untapped information before them in form of structured, semi-structured, and unstructured data. Okay, so today most of data are in terms of unstructured. So 80% of data today we retrieve in terms of unstructured. If it is structured manner, so no problem, we can done analytics and we can get decision and we can go for any type. Okay, so if the data is unstructured and semi-structured, we need some terminologies, technologies to tackle with those unstructured data. Okay, so this varied variety of data is spread across the network. So how we going to deal with this kind of unstructured and semi-structured data? Okay, so we need some terminology and technology we need. Okay, so such a framework we have is Hadoop. Okay, so Hadoop plays a vital role in big data. Okay, big data nothing but it deals with big volume of data, big varieties and velocities of data. So how we going to manage, process and how we going to analyze those data? So we need some framework. So that framework is called Hadoop. Okay, so before going into Hadoop, let us look at few statistics to get an idea of amount of data which gets generated every day, every minute, and every second. So here is some statistics on about data. Okay, so every day, New York Stock Exchange generates 1.5 billion search and trade data per day, and Facebook stores 2.7 billion commands and likes per day. Google processes about 24 petabytes of data per day. So coming to every minute, Facebook users SaaS nearly 2.5 million pieces of content. Twitter users tweet nearly 300,000 times. Instagram users post nearly 220,000 new photos. YouTube users upload 72 hours of new video content every minute. Email users send over 200 million messages per minute. Amazon generates over $80,000 in online sales. Google receives over 4 million search queries per minute. Okay, so for every second, banking application process more than 10,000 credit card transaction every second. Okay, so data plays a major role in today's enterprises. Okay, so how a data we can call a data as a treasure trove. So treasure trove nothing but it is a collection or store of valuable things. Okay, so today data plays a major role. So with the raw data, we can't proceed with analytics and all. So we have to convert those raw data into knowledgeable information, so that every enterprises organization, they go process with their knowledgeable information only, they going to take decision. Okay, so for that they have to convert those raw data into meaningful information, nothing but knowledgeable information. So for converting those raw data into knowledgeable information, so we need some terminology, we need some technology to convert those raw data into knowledgeable information. So such a framework big data have is Hadoop. Okay, so coming to data, it provides business advantages such as generating product recommendation, inventing new products, analyzing the market, and many and more. It provides few early key indicators that can turn the fortune of business. So it process, analyze, and make sense of these different kinds of data. So these are all some of the importance of how today's generation play with data. Okay, so now we know what are all the challenges of big data. So we have how we going to tackle big volume of data, how we going to tackle big variety. So variety is nothing but images, audios, videos, application, source code, etc., and also structured data, unstructured, semi-structured. So we deals with some different kind of varieties of data. Not only we going to deal with structured data, we also deal with unstructured and also semi-structured. So how we going to tackle those varieties of data and the huge complex of data, and how speed at which being data being received. So these are all some of the challenges a big data enforces. So how we going to face these challenges, how we going to tackle, how we going to convert those challenges. Okay, so for that we need one framework, we need some technology to tackle with big volume, big variety, and velocity of data. So such a framework we have is in big data is Hadoop. Okay, so why Hadoop? So the main key consideration why most of enterprises they go for Hadoop kind of framework. Okay, its main capability to handle massive amount of data, and it deals with different categories of data, and we can make our own decision quickly. So that an enterprises organization, they prefer Hadoop kind of framework in their enterprises. Okay, so here why enterprises they go for Hadoop? So the main 5 features why they prefer Hadoop. Okay, so the first one is low cost computing power, scalability, storage flexibility, and inherent data protection. So coming to low cost, since it is an open source framework. Okay, since it is an open source framework and it uses commodity hardware, so not a perfect server for holding every data. Okay, it uses commodity hardware, nothing but it relatively inexpensive and easy to obtain that hardware. Okay, since Hadoop is distributed type of process, so system capable of running different OS. So Hadoop doesn't require very high-end server and all. Okay, so that cost-wise it is very low. And second, computing power. Okay, Hadoop is based on distributed computing model, which process very large volume of data. Okay, the more number of computing nodes, the more the processing power at hand. Okay, so scalability, coming to scalability, we simply adding nodes as the system grows, and it requires much less administration. If my data grows exponentially higher day by day, so we can simply adding another node in my cluster. So scalability doesn't problem in Hadoop. Okay, so coming to flexibility, so unlike traditional RDBMS, Hadoop data need not to be pre-processed. So in traditional relational database management system, so they use data warehousing kind of server. Okay, in order to hold and store data. Okay, so in traditional relational database management system, they prefer data warehousing kind of environment in order to tackle and manage and access analysis those data. Okay, so for data warehousing kind of environment, we need to pre-process those data before we keep on those data into that server. Okay, in Hadoop and all, we need not to be pre-process those data before storing it. Okay, so in Hadoop, one can store unstructured data like images, videos, source code, Facebook content, so any social media data, etc. Okay, so we need not to be pre-processed before storing it in Hadoop. Okay, so such flexibility we have in Hadoop kind of framework. Okay, so coming to data production, so Hadoop protects data and executing application against hardware failure. So if a node get failure, it automatically redirects the job that have been assigned to particular node to some other available node and ensures that distributed computing does not fail. So for that, replication factor plays a vital role in Hadoop. We have replication factor. Suppose if any of node get failure at computation, okay, so it automatically redirects that job assigned to particular node to some other available node and ensure to keep on running. Okay, so these are all some of main features of Hadoop. So why an organization or enterprises they prefer this kind of framework in their enterprises? Okay, so next, why they not prefer RDBMS? We know it is a traditional database system. Okay, so RDBMS is well suitable for structured data and a small amount of databases. But in big data, we deals with varieties and big volume of data. So in order to cope up with big volume and varieties of data, so RDBMS is not suitable for storing and processing large file, especially images, videos, social media data, etc. Okay, so it is not a good choice when it comes to advanced analytics like deep learning, machine learning kind of processing. Okay, so it is not a good choice for prefer RDBMS. So we have switched over to another framework called Hadoop. Okay, in order to deal with advanced analytics and in order to deal with big storage and processing large amount of database, we have to switch over to Hadoop kind of framework. Okay, so in this diagram, it clearly declined the respect to a cost and storage of using RDBMS. So mainly RDBMS is well suitable for storing small amount of databases. If my data growth gets exponentially get growth high, so it is not a best choice for prefer RDBMS. Okay, so here is some comparison between RDBMS and Hadoop system. It is a relational database management system, whereas in Hadoop, it always based on node-based flat structure. A data RDBMS well suitable for structured kind of data, whereas my Hadoop kind of framework is suitable not only for structured, it also prefer unstructured and semi-structured data, and most of real-time data it deals with. Okay, so processing RDBMS online transaction processing, whereas in Hadoop analytical kind of processing like deep learning, machine learning, and all. Okay, so processor RDBMS needs some expensive hardware and high-end processor, whereas for my Hadoop I need some commodity hardware in order to tackle, since it is a low cost, and since Hadoop is distributed type of process, we can capable of running different OS, so it doesn't require a high-end server and all. Okay, so cost wise RDBMS cost around $10,000 to 114,000 per terabytes of storage, whereas in Hadoop they cost around only $4,000. So in cost wise, in storage wise, in computing power, flexibility, data production, so nowadays enterprises prefer Hadoop kind of framework in order to storage, processing, and manage and accessing my data. Okay, so coming to Hadoop. Okay, so what is Hadoop? So it is an open source framework, mainly the project of Apache Foundation. So the programming language written is Java. It was initially developed by Doc Cutting in the year 2005. The name who named it after his son's toy elephant. So it is not specific name. It's a random name of toy's name. Okay, so he was initially working with Yahoo. Hadoop uses Google's MapReduce and Google file system technology as its foundation. Okay, so coming to MapReduce. So MapReduce is a programming model mainly used for processing a big amount of data. So how data are integrated, how we going to process large amount of data. So for that we need a programming model called MapReduce. Okay, so now Hadoop is a core part of major companies like Yahoo, Facebook, Twitter, LinkedIn. So most of companies they prefer Hadoop kind of framework. So here is architecture of Hadoop. Okay, so Hadoop, we know it is an open source software framework by Apache Foundation. Initially it was inspired by Google MapReduce and Google File System. Here in Hadoop we have two major core component of Hadoop. One is Hadoop distributed file system and another one is MapReduce. So HDFS. So Hadoop distributed file system is the key component for storing massive large amount of data. Okay, so the main responsibility of Hadoop distributed file system is keep storage large and massive amount of data across our system. Okay, the second major component is MapReduce. So the job of MapReduce is to processing data. So how we going to process the massive amount of data that's stored in a Hadoop system? Okay. Yes, here is the history of Hadoop. We know Hadoop was created by Doug Cutting in the year 2005. He was inspired by Google's MapReduce and Google file system. Initially, he was part of Yahoo project and also part of Lucent project. So in the year 2005, 2004, he was inspired by Google file system and MapReduce. So in the year 2005, he was part of Yahoo and he was creating that Hadoop framework in the year 2005. Later on, he joined Cloudera. So after that, the Hadoop 1.0 became Hadoop 2.0 version. Some initiatives, some additions are done in the year 2009. Later on, we're going to see what in Hadoop 1.0 version and what are in Hadoop 2.0 version. Okay. So here are the some key aspects of Hadoop. We know it is open source software, so it is free to download and free to use and easy to contribute to our client application. Okay, so since it is an framework, yeah, means everything that you will need to develop and execute and application is provided already. So it is distributed manner, so it stores our data across multiple machines. Okay, so computation or processing is done in parallel manner across multiple connected nodes, and essentially it is a massive storage. So we store a huge and large amount of data across our system, since it doesn't require any high-end server, and also we use commodity hardware in order to tackle with storage, and it is fast processing. So large amount of data is processed in parallel manner. So a quick response we can yield it in Hadoop. Yes, already we have seen some versions of Hadoop. So here we're going to see two different versions of Hadoop available. One is Hadoop 1.0. Nowadays we prefer Hadoop 2.0. So what's the major difference between Hadoop 1.0 version and Hadoop 2.0 version? Okay, so already we know the two major component of Hadoop is HDFS and MapReduce framework. Okay, so the HDFS framework is mainly essential for storing large amount of databases. Okay, so it's mainly for storage purpose. And second, MapReduce, the job is for processing those data. So how data are integrated, how they're going to process. Okay, in Hadoop 1.0 version, the job of MapReduce is not only processing data, and also the job is to allocate resource manager for different client application. Okay, so in Hadoop 1.0 version, the MapReduce job is not only processing data, also looking to allocate the resources to various client application. But in Hadoop 2.0 version, the main job of MapReduce is only processing data. So the cluster resource manager is done by Yarn module. So Yarn nothing but yet another resource negotiator. Okay, so here in Hadoop 2.0 version, we have separate resource manager that called Yarn, nothing but yet another resource negotiator. So it is an advanced form of Hadoop. Okay, so nowadays most of enterprises organization, they prefer Hadoop 2.0 version. Okay. Here is the component of Hadoop ecosystem. Okay, so the two major component already we seen. One is HDFS and another one is MapReduce programming. So some of another major component available in Hadoop are Hive, Flume, Uzi, Pig, Mahout, Scoop, HBase. So here are some of ecosystem, some other major component that assist with this MapReduce programming and Hadoop distributed file system. So one by one we're going to see. Okay, first of all, we're going to see two major component. One is HDFS and second one is MapReduce. So HDFS, the main job is storage. It acts as storage component. So the job is to store massive amount of data across several machines. Okay, it distributes data across several nodes. Okay, so the job of MapReduce is it's going to process those data in parallel manner. So it acts as some computational framework. Okay, it splits a task across multiple nodes. and Hadoop ecosystem or support projects to enhance the functionality of Hadoop core components. Some of echo projects are as follows: Hive, Pig, Scoop, HBase, Flume, OZ, Mahout. So these are all some of core minor component of Hadoop that supports or enhance the functionality of Hadoop core component that assist HDFS and MapReduce programming. So one by one we're going to see. First we're going to see Pig. So pig, nothing but it uses Latin word pig to specify data flow. Okay, so pig is a data flow system for Hadoop. It is an alternative to MapReduce program. Suppose if my MapReduce programming gets some fault, so I can prefer pig kind of data flow system. Okay, so it abstracts some details and allow us to focus on data processing. So we know MapReduce programming is a programming model that going to assist processing those data in parallel manner. Okay, so it is alternative to MapReduce programming pig. So its main job is to abstract detail and allow us to focus on data processing. Okay, so next one, Hive. So Hive is a data warehousing layer on top of Hadoop. So analysis and queries can be done using an SQL-like languages. Okay, so the main job of Hive is to analyze those data in Hadoop. Okay, we can give, it is like SQL-like languages. We can it can use it to Hadoop query summarization. We can mainly it Hive is used for analysis kind of purposes. We can use Hive. Okay, Scoop. So Scoop is a tool which help us to transfer data between Hadoop and relational databases, nothing but local file system. So how I'm going to transfer my data in local file system to Hadoop. Okay, so here I have a Scoop kind of tool which help me to transfer the data from local file system to Hadoop. Okay, so with the help of Scoop, we can import or export data from RDBMS to HDFS or HDFS to RDBMS. So it mainly it is a import and export tool. Mainly help us to transfer our data from local file system to Hadoop, vice versa. And HBase. So HBase is a NoSQL database. So NoSQL nothing but not only SQL, it is an opposite term of structure query languages. Whereas in SQL databases, most of data are structured, whereas in NoSQL databases, the data are in unstructured manner. Whereas in SQL, here HBase is a NoSQL databases for Hadoop. It is a column-oriented NoSQL databases. Okay, so it mainly it used to store billions of rows and millions of columns. Okay, so mainly essential for read-write operation. We can use HBase. Okay, it mainly essential for storage purpose. It going to assist Hadoop distributed file system. And some of core component like Uzi. So Uzi is a it is a workflow scheduler system to manage our Hadoop jobs. So the main job is to allocate scheduling. Okay, and Zookeepers is a coordination service for distributed applications. So yeah, these are all some of the ecosystem, nothing but some of the minor components that going to assist our Hadoop distributed file system and MapReduce programming. Okay, and the core component we already discussed. Here we can see the Hadoop conceptual layer. Okay, so it is conceptually divided into data storage layer, which shows huge volume of data, and another important conceptual layer called data processing layer, so which process data in parallel in order to extract richer and meaningful insights from data. So that we can call Hadoop distributed file system and MapReduce system as a conceptual layer of Hadoop. So one of two major component that plays a major and vital role in Hadoop. Okay, and here is the high level architecture of Hadoop. So we can call Hadoop is a distributed master slave architecture. Okay, so master node is called also known as name node, and slave nodes are also called as data node. Okay, so in master node the main job of name node, so name node is also called as master node, and data node is also called as slave node. Okay, so master node is the main job of master node is to keep track the location of various data nodes. Okay, so it's going to keep track the location of various data nodes, and it's going to maintain the properties of data that are all stored in data node. So the main job is to allocate various resources to data nodes. Okay, so name node is also called as master node. So the main job of data node is to keep keep of all data that are given by name node. Okay, so one by one we're going to see what is master node and what is data node. Okay, so in master node we have master HDFS and master MapReduce. So we already know what is HDFS and what is MapReduce. So HDFS is keep track the data. It is mainly used for storing data, and MapReduce, the main job is to process those data. Okay, so here in master HDFS, the main responsibility is partitioning the data storage across the slave nodes. Okay, so the data are stored in various data nodes. Okay, so here master HDFS, the main responsibility is partitioning those data, incoming data. It going to maintain those data properties, and also it going to keep track the locations of data on data nodes. So what's the job of master MapReduce? So its job is to decide and schedules computation task on slave nodes. Okay, so first we're going to see what is Hadoop distributed file system. Okay, so we already know it is storage component of Hadoop. It is distributed in manner, whereas in traditional RDBMS we use data warehousing. So data warehousing is centralized repository, whereas in Hadoop we use Hadoop distributed file system. It is distributed in manner. Okay, so it model after Google file system. It is high throughput, and we have replication factor. If one node get failed, it automatically, it manually it alter that job to some other data node free at that time. So replication factor plays a vital role in Hadoop distributed file system. Okay, and we can realize the power of Hadoop distributed file system when you perform read or write on large files. So it deals with a big amount of databases. So we can realize the power of Hadoop distributed file system when we performing read and write on a large number of files. Okay, and here is the architecture of Hadoop distributed file system. As a client, I'm going to interact with the Hadoop. Okay, so initially my files are stored in Hadoop. Okay, so suppose for example I'm having sample.txt. So already we know what is name node and what is data node. So name node, the job is to allocate and maintain the data properties of various data that's stored on data node. Okay, so name node only going to allocate various jobs to data node. So the job of data node is keep track the storing various data that is assigned by name node. Okay, for example, client application is interact with name node for metadata related activities and communicate with data node to read and write files. So let us assume that the file sample.txt. So here in diagram you see sample.txt. Okay, so my sample.txt is of size 192 MB. So as per the default data block size is 64 MB. Okay, so each and every node so have size of default size is 64 MB. For example, my sample.txt is 192 MB. So how name node keep track that particular sample.txt? So since we know the block size is 64 MB, so here we have three different block called block A, block B, block C, each of 64 MB. So like vice versa. So depending on my input data size, such the data nodes are generated. Okay, so as per the default data block size 64 MB, it will be split into 3 blocks and replicated across the nodes on the cluster based on the default replication factor. Okay, so that in data node A, data node B, data node C, I have three different replicas present. Suppose if my data node A get failure, okay, so automatically that job is done by another data node called B. Suppose data node B get failure, so another data available in data node C. So replication factor plays a vital role in Hadoop distributed file system. Already we studied our fault tolerant. Okay, it is So if any node get failed, it automatically redirect the job that had been assigned to that particular node to some other available node. So here my block A, block B, block C is stored in node A, node B, node C. So not only my data is stored in data node A, so it replicated in data node B and also replicated in data node C. So here replication factor is 3. So if my node A get failure, so automatically it redirect that job that have been assigned to A to some other node called B or C. Okay, so replication factor plays a vital role in Hadoop. Okay, so here one by one we're going to see in HDFS. So HDFS two major daemons. We can't call it as daemons. Okay, so daemons are background computing features. So how it going to run background. Okay, so name node and data node is a two node available in HDFS. We know Hadoop distributed file system is essential for storing our data. Okay, so since we are receiving major amount of data in terms of dynamic real-time data, so how we going to accommodate those data in my system? Okay, so that Hadoop distributed file system plays a vital role in storing that massive amount of databases. So here in Hadoop distributed file system, I have two different node. One is master node or name node, and another node is data node or slave node. It is a master slave architecture. We can call Hadoop is a master slave architecture. Okay, so here one by one we're going to see. So first we're going to see what is name node. Okay, so name node is also called as master node. So Hadoop distributed file system breaks a large file into smaller pieces called blocks. So blocks nothing but nodes. Okay, so we know the size of each and every block is 64 MB. Okay, so according to my input file, I can break that input file into number of pieces, that is called nodes. Okay, so in previous example, if I receive 192 MB of file, so I can divide that 192 MB of file into three major pieces, nothing but blocks. Okay, so each and every block holds 64 MB of data. So 64 into 3, I can accommodate 192 MB of data. Okay, so according to input data size, I can split those input file into smaller pieces called blocks. So each and every block holds 64 MB of data. Okay, so here name node uses a ID, it called rack ID, in order to identify data node in the rack. Okay, so a rack is nothing but it is a collection of data node within the cluster. So a cluster have n number of data nodes. Okay, so what's the job of name node? So name node keeps track of blocks of a file as it is placed on various data nodes. Okay, so its main activity is read, write, create, delete. So all file related operations are done by name node. So the main job is to managing file system namespace. Okay, so here in name node, it manages file related operations such as create, delete, write, read, etc. Okay, so here we're going to see two important namespace. One is FSL image, another one is edit log. Okay, so what is called FSL image? Okay, so file system namespace includes mapping of blocks to file properties and how it is stored in a file. So that is called FSL image. Okay, so FSL image keep track the entire properties of file. Okay, so whereas in edit log, so edit log is also called as transaction log. So it going to records every transaction that occurs to file system metadata. Okay, so edit log keep tracks of transaction history, whereas FSL image it holds the history of file properties that stored in our system. Okay, so nothing but file properties. Okay, so here in name node it maintains two different file related operation. One is FSL image and edit log. One going to maintain file properties and another edit log going to maintain the transaction history. So who are all interact with my system, so what transaction done in my system, and all, and the read and write operations are going to maintain by edit log transaction. Okay, so second node called data node. Okay, so data node also called as slave node. Okay, so there are multiple data node per cluster. So already we know, so per cluster we have n number of data nodes. Okay, so accordingly there are multiple data nodes per cluster. So during read and write operation done by client application, nothing but during pipeline read and write, data node communicate with each other. So how a communication that taken place between data node and name node. Okay, a data node also continuously send heartbeat message to name node to ensure the connectivity between name node and data node. Okay, so in case there is no heartbeat from a data node, so the name node replicates that data node within the cluster and keeps on running as if nothing had happened. So here you can see it in this diagram. Okay. Okay, so here, so how the communication that taken place between name node and data node. So already we have seen data node send some heartbeat messages to name node. Suppose if name node doesn't receive any heartbeat messages from any of data node, so it automatically replicate that job to some other data node available at that time. So here in this diagram you can see. Okay, so there are several data nodes we have, and name node only responsible for allocating that job to data node. If I'm a client, so I'm going to interact with Hadoop, I'm going to read or write a large number of files in Hadoop system. So n number of clients at a time going to interact with Hadoop. So the resources is allotted by Hadoop system, so that the job is done by yet another resource negotiator. So that and all run in background features. Okay, so how the job is assigned to data node. Okay, so if data node is ready, so data node acknowledges name node by giving heartbeat messages to name node. If name node receive such heartbeat messages, then automatically that job is assigned to particular data node. If no heartbeat messages received by name node, so it replicate that job to some other data node available at that time. So since this how the communication that taken place between name node and data node in Hadoop. Okay, and also not only in Hadoop distributed file system, we already seen two important core component. One is name node, another one is data node, nothing but master slave architecture. So master node, another one is slave node. So another node available called secondary name node. Okay, so the what is secondary name node? So the secondary name node takes a snapshot of HDFS metadata at intervals specified in the Hadoop configuration. So it is nothing but it is an alternate to name node. Okay, so in case of failure of name node, the secondary name node can be configured manually to bring up the cluster. So we know the important features of name node. So name node only going to keep track of a transaction history and file managing, operation file, system properties, all scheduling, managing purpose, all done by name node. Suppose so in Hadoop, there are only one name node. Okay, in case of any failure that happened to my name node, the secondary name node can be configured. We can create it manually. We can configure manually to bring up the cluster. So, however, the secondary name node does not require any real-time changes that happen to the Hadoop distributed file system metadata. So how we going to work with HDFS command? So here some of HDFS command here I'm giving. So how I'm going to list the directories and file at my Hadoop distributed file system. In order to list directories, I have command Hadoop fs nothing but file system -ls. So ls nothing but to get the list of directories and files at the root of HDFS. So how I'm going to create a directory in Hadoop distributed file system. So for creating a directory, I have to give make directory. So Hadoop fs nothing but file system -make directory, mk directory. So the directory name sample. Okay. So by this way, I'm going to create a directory in Hadoop distributed file system. Suppose I'm going to copy a file from local file system to HDFS. Okay. So for copying a file from local file system to HDFS, I'm going to use put command. So similarly, for copy a file from Hadoop distributed file system to local file system, I'm going to use get command. So this is the difference between put command and get command. Okay. So put command is used to copy a file from local file system, that is C drive, any desktop. Okay. So how I'm going to copy a file from local file system to HDFS? I am going to use put command. Whereas to copy a file from Hadoop system to my local file system, I'm going to use get. Next, source destination, source and destination. Okay. So here are the some of the sample of HDFS command. Okay. Okay, so that's about HDFS. Okay, so we covered storage component. So the main job of HDFS is storage component. So how my data are distributed across my system or machines. So how it is stored. So for that we have seen three important daemons called name node, data node, and secondary name node. So secondary name node nothing but it is an alternate to name node. So if my name node get failure, then automatically we configure manually the secondary name node. It keep track the file properties and going to maintain record transaction history of various data. So this the job of data node is to keep storing the various data that is assigned by name node. And also we seen how the name node and data node are going to communicate with each other. Okay, so the main job of Hadoop distributed file system is mainly for storaging our data. Okay, the second we're going to see, we're going to cover in today's topic is MapReduce programming. Okay, so MapReduce programming is also a framework. It is a programming model that going to process massive amount of data in parallel manner. Okay, so in MapReduce programming, so our input data set is splitted into independent chunks. So here my input file is going to split into different independent chunks. Okay, so here we have two important tasks. One is map task, another one is reduce task. Okay, so what is mapping and what is reducing? Okay, the job of map task. So map task process those independent chunks completely in a parallel manner. Okay, so the output of map task is given to input to reduce task. Okay, so the output of mappers are automatically shuffled and sorted by the framework called MapReduce framework and sort the output based on keys. That sorted output becomes the input to the reduced task. So in future slide, we're going to see example of MapReduce programming, how the input data set is split into independent chunks. So how mappers are going to perform and how reduced tasks are going to perform. We can see it in by one example. Okay. Okay, the main job of reduce. Okay, the reduce task provides reduced output by combining the output of various mappers. Okay, so the job inputs and outputs are stored in our file system. Okay, the map reduce framework also take care of other tasks such as scheduling, monitoring, re-executing failed tasks. So the job of map reduce framework is not only for processing tasks, and also it also take care of some other tasks such as scheduling, monitoring, re-executing failed tasks. So these are all the some of another features of MapReduce programming. Okay, so Hadoop distributed file system and MapReduce framework run on the same set of nodes. So not separate node for MapReduce, not some separate node of file system. So both framework run on the same set of node. The configuration allows effective scheduling of tasks on the node where data is present, so that we have high throughput in Hadoop kind of framework. Okay, so processing data with Hadoop. So here there are two different daemons that are associated with MapReduce programming. One is job tracker and another one is task tracker. So what is job tracker and task tracker? And job tracker, the main job is to schedule task, and whereas in task tracker the main job is to execute this task. Okay, so the task is going to schedule by job tracker and the particular task is executed by task tracker. Okay, so we can also call job tracker as master task and task tracker as slave task. Okay, so in HDFS we seen two different daemons called name node and data node. So vice versa in MapReduce programming we have two different daemons, one called job tracker and another job called task tracker. Okay, so the job of job tracker is to scheduling and the job of task tracker for executing those tasks. Okay, so already we have seen two different phases of MapReduce. One is mapping and another one is reducing. So the job of mapping is to convert those input data set into key value pair, and the job of reducer is to combine those output of mapper and produce a reduced result set. Okay, one by one we're going to see in this slide. Okay, one is job tracker, another one is task tracker. So job tracker also called as master one, and task tracker also called as slave one. Okay, so in job tracker it provides the connectivity between our Hadoop and our application. So as a client I'm going to interact with Hadoop. So initially my job is taken by job tracker. So job tracker, the main job is to create the execution plan by designing by decide which task to assign to which node. So the main job of job tracker is to scheduling the task to the task tracker. Okay, so the job tracker is a master daemon that is responsible for executing overall MapReduce job. Okay, so there is a single job tracker per Hadoop cluster. Okay, so another daemon called task tracker. So the task tracker is responsible for executing individual tasks that is assigned by the job tracker. Okay, so the master one going to scheduling the different tasks to task tracker. So the job of task tracker is to executing those tasks that given by the master one. Okay, so here there is a single task tracker per slave, and spawns multiple Java virtual machine to handle multiple map or reduce tasks in parallel. Okay, so here how the job tracker and task tracker are going to interact. Likewise, we have seen in how the name node and data node are going to interact. So here also the task tracker continuously send heartbeat messages to job tracker. When the job tracker fail to receive any heartbeat from a task tracker, then particular the job tracker assumes that the task tracker has failed and resubmit that task to some other available node in the cluster. So like HDFS, we've seen how the communication that taken place between name node and data node, some heartbeat messages that the data node acknowledges name node. So similarly, here also task tracker is continuously send heartbeat messages to job tracker. If the job tracker fail to receive heartbeat messages from task tracker, then automatically a job tracker assumes that the task tracker failed and resubmit that particular task to some other available node in the cluster. So once the client submit a job to job tracker, it partitions and assigns the MapReduce task for each task tracker in the cluster. Okay, so here is the job tracker and task tracker interaction. So how the task tracker going to interact with the job tracker. Okay, suppose if job tracker fail to receive heartbeat messages from any of task tracker, so then automatically it assign that particular job to some other task tracker. Okay, so how does our MapReduce works? Okay, so we already know two different phases of MapReduce. One is mapping and another task is reduce task. Okay, so whatever input file we receive, so we have to convert those input data set into independent checks. That means a key value pair. Okay, so the main job of map task is to convert those input data set into key value pair. Okay, so it will process in parallel manner, and the shuffled and sorting output is given to reduce task. Okay, so the job of reduce task is to consolidate the reduced output data set and it given to final output. Okay, so that particular output is given to client application. Okay, so here is the architecture of MapReduce programming. So various clients are going to interact with job tracker. We know two different daemons that present in MapReduce programming. One is job tracker and another one is task tracker. So the job of job tracker is to scheduling the jobs. Okay, it only going to assign to different various task node. So the job of task tracker is to execute the particular task that assigned by job tracker. Okay, so the final output is received by client application. Okay, okay, so here is the architecture summary. Okay, so first we have the input data set is splitted into various pieces of data, so nothing but small subset. So next the framework creates master and several worker process and execute the process remotely. Okay, so we have two different phases, one called map task and another called reduce task. Okay, so the map task works simultaneously. It going to read pieces of data that were assigned to each map task. So the map worker uses the map function and it going to extract those data that are present on the server and generate key value pair for the extracted data. So okay, So map worker uses partitioner function to in order to divide the data into regions. Okay, so the partitioner design, the partitioner only going to decides which reducer should get the output of the specified mapper. Okay, so when the map workers complete their work, the master instruct the reduce worker to begin their work. Okay, so we know two different phases, one called map phases, another called reduced phases. So the map phase, the main job of map phase is to convert the input data set into independent chunks and going to convert the particular input data set into key value pair. Okay, and work parallelly. Okay, so the next job is reduce work. So the reduce work is going to receive the output of mapper and it going to shuffled and sorted as per p. Then it called reduce function for every unique key. This function writes the output to the file. Okay, so when all the reduce workers complete their works, the master transfer the control to the user program. So the final output is produced to client application. Okay, so here we're going to see one example. So how our map reduce programming works. Okay, so the famous example for map reduce programming is word count. So the how it going to count the words. We suppose if we give some input file. Okay, so some document we going to give. So how we going to count those input data sets? How the input data set is mapping and reducing? So how it going to produce the result data set to client application? Okay, so here we going to consider you need to count the occurrence of similar word across 50 files. Okay, so here we can use MapReduce programming. We know MapReduce programming is a programming model. It is written in Java. Okay, it is a framework programming model mainly used to process data. So how my input data file, how it going to process? Okay, suppose I'm going to give input data set some of keys. Okay, Hadoop, definitive, guide, Hadoop in action, map, reduce, design, patterns. Okay, so this is my input data file. I'm going to save it as input.txt. For example, here word count.txt. Okay, so in that I can give some n number of words. Okay, so here I'm giving 3 6 some 10 words I'm giving. Okay, so here my first step is input data set is divided into independent chunks. So here my input data set is divided into 3 independent chunks. Okay, so first independent chunks Hadoop definitive guide, and second independent chunk Hadoop in action, and third independent chunk map reduce design pattern. So here my input data set is converted into 3 different mappers. Okay, so here I'm going to use first phase called map phase to my input data set. So what's the job of mapping? So the job of mapping is to convert those input data set into key value pair. It's going to convert my input data set into key value pair. Okay, so first map, mapper 1, mapper 2, mapper 3. So in my first map, so what are all the keys? Okay, so the keys are Hadoop, definitive, and guide. Okay, so how many times the particular word Hadoop occur? So only one time occur. So Hadoop comma 1. So key comma value. So key value pair. Okay, so how much time my definitive occur? So only one time the word definitive occur. So key value pair is definitive comma value means 1. Okay, so how much time the word guide occur? Okay, so guide is the key and value one time occur. Okay, so likewise, we're going to convert the input data set into key value pair. Similarly, in mapper 2, Hadoop in action. So Hadoop is my key and it occur one time. So Hadoop comma 1. So in is my key, it occur one time. So action, the word occur one time. Okay. So accordingly, we're going to convert the input data set into key value pair. So what's the next job is done by mapper means it's going to shuffle and sorting. Okay, so here I'm going to shuffle my mappers and sorted into descending order from A to Z. Okay, so likewise the shuffling and sorting is done in mapper. So then the output of mapper is given to input to reduce phase. So here what's the job of reducing? So the reduce phase is going to consolidate the reduced output data set to client application. So here you seen it in example shuffle and sorting. So the Hadoop occur 2 times. Okay, so in first mapping phase, Hadoop the word occur, and in second phase, Hadoop occur. Okay, so in reduced data set, it consolidate the word Hadoop one time and the value as 2. So likewise, the whole processing is going to in reduced phase, the reduced data output data set is given to client application. Okay, so in MapReduce programming, we see two different phases. One is map phase, another one is reduce phase. The job of mapping is to convert the input data set into key value pair. So any number of input data file we receive, we going to divide those input data set into independent chunks. So here in my example, I divide my input data file into 3 different independent chunks called 3 different mappers. Okay, next the job of mapper is to convert the input data set into key value pair. So I'm going to convert my input data set as a key value pair. So next job is to shuffle and sorting, so from descending order, okay, from A to Z. Next, reduce data set is going to reduce the output data set. Okay, so here in mapper phase, the word Hadoop occur twice, two different mappers. So in reduced data set, so the word is consolidated to single. Okay, Hadoop, the value is 2. Okay, so likewise our output data set is produced to client. Okay, so we know MapReduce programming is a programming model that is written in Java. So how this MapReduce programming work? Okay, so since it's written in Java, we need to download Eclipse. So we have to open Eclipse and it open Eclipse file new, and we have to create new Java project name. Okay, so like MapReduce program demo, and we have to click finish. So after creating project, we need to create package. So we have to create package, and after finishing our package, we need to create class. Okay, for example, if my program is word count, I'm going to give class name as word count. Next, I'm going to add some reference library to my project name package demo. Okay, so next I'm going to write program on MapReduce programming. So here input data set, I'm creating one input file called word count.txt, and in word count.txt I'm giving some 50 words and all. Okay, so that is the input to data set. So here MapReduce programming, what the job of MapReduce programming means, that particular input data set is received by Hadoop kind of system. So the particular Hadoop kind of system, here we have two different tasks. Okay, job task and the task tracker. The job tracker is going to scheduling the job to different task tracker, and task tracker is going to execute that task. Okay, so two different phases we have. One is mapping phase, another called reduce phase. The job of map phase is to convert those input data set into key value pair, and after shuffling and sorting, the job of reduced phase is to reduce the data output data set that received by mappers. Okay, and we have covered so far, we have covered two major component, one called Hadoop distributed file system, and another one is MapReduce programming. So we have already seen Hadoop 1 version and Hadoop 2 version. Okay, so in Hadoop 1.x version, we have only two major component, one is HDFS and another one is MapReduce programming. Okay, whereas in Hadoop 2.x version, we have another module called yet another resource negotiator. Okay, so this particular module is going to manage the resource and application with Hadoop. Okay, so here we can see the difference between Hadoop 1.x version and Hadoop 2.x version. Okay, in Hadoop 1.0 version, we have only two component, HDFS. The job of HDFS is for storaging, and the job of MapReduce for processing those data. So in assist to processing, it also look after the resource management also. Whereas in Hadoop 2.0 version, we have separate module called Yarn. So Yarn nothing but yet another resource negotiator, nothing but cluster management. Okay, so at a time a different client application going to interact with Hadoop. So the job of Yarn module is going to allocate the resource for different client applications. So how many memory, how much resources, CPU, the particular client going to interact. Okay, so the job of Yarn is to allocate the resource management. The job is to done by yet another resource negotiator. Okay, so okay, that the future Hadoop 2.x can. Okay, so nowadays Hadoop can be used for various type of processing, such as not only deals with batch processing, it also deals with interactive online graph and etc. Okay, so what are all the limitations of Hadoop 1.0 architecture have? Okay, so here single name node is responsible for managing entire namespace for Hadoop cluster. Okay, so the MapReduce job is not only for processing data and also look after the resource allocating to various client application. Okay, so the Hadoop 1.x version is not suitable for deep learning, machine learning kind of algorithm, intensive algorithm and all. Okay, so that we need to elevate our Hadoop 1.x version in order to spend a special module called cluster resource management and data processing. Okay, so that we have Hadoop 2.x version. So now in today's world, okay, so the most of enterprises organization, they prefer Hadoop 2.x version. Okay, so here we have separate module called yarn. So yarn nothing but yet another resource negotiator. It takes our Hadoop beyond batch processing. Okay, so nowadays we deal with deep learning and machine learning algorithms. So our title is also deep learning application and challenges in big data. So one of the major challenges what big data face is storage and processing. So here Hadoop answer those questions that raised by various applications, such as how the storage, how processing going to happen. So this particular yarn module taking the Hadoop beyond batch. Okay, it not only performing processing batch, it also performing interactive, it also performing real-time application, online streaming, in memory, and other algorithms such as graphing, searching, etc. So this particular module called yarn that taking our Hadoop beyond batch processing. Whereas in Hadoop 1.x version, the job of MapReduce processing is not only to processing data and also look after the cluster resources also. Whereas in Hadoop 2.x version, we have separate module called yet another resource negotiator. This particular module taking Hadoop beyond batch. Okay, so the major challenges in today's world. Okay, we live in digital era. We going to face millions and billions of data. We day to day we receive huge amount of data. So how we going to tackle those data? So how we have two major challenges. One is storage and another one is processing. Okay, so for storaging, we have separate feature called Hadoop distributed file system. It is responsible for storage our data across several machines in distributed manner. And second one, how we going to integrate those data that stored in Hadoop system, how we going to process those data. So that called MapReduce programming. Okay, so the main job of MapReduce programming is to integrate those data, and it uses a special framework called map phases and reduce phases, and in order to deal with massive amount of databases. Okay, okay, thank you. So today we covered what is Hadoop and why an enterprises organization they go for Hadoop. Okay, we cover Hadoop architecture. The main two core component of Hadoop, one is Hadoop distributed file system, and another called MapReduce programming. So in Hadoop 2.x version, we have another separate module called yet another resource negotiator. It take our Hadoop beyond batch. Okay, nowadays we it deals with real time interactive online graphing data like machine learning, deep learning and all. Nowadays it deals with Hadoop 2.x version rather than Hadoop 1.x version. So thank you, ma'am. So thanks to every participants.
Thank you, sir. Thank you for sharing your knowledge on this particular topic. And again, thank you for sharing your time and experience with us all, sir. Participants, any queries? Okay, thank you. Okay, sir. Thank you, sir.
Thank you, ma'am.
So,
Thank you, ma'am. Thanks
okay,
for all participants.
okay, sir. So next session will start at 2:45. Participants, you can join at 2:45. back you all for the next session. It's my great pleasure to introduce Dr. V. Srinivasan sir, the session speaker for the this current session. He has completed his UG degree in computer science at Bharadasan College of Arts and Science, Erode. He completed PG degree MCA in computer applications at Kong Engineering College, Erode. He has completed MPhil degree in Alahapa University, Karaikudi in the year 2006, and he completed his PG degree in the year 2014 from Anna University, Chennai. He had published 8 research papers in various national and international journals. He has presented a number of research papers in many national and international conferences. He is also the reviewer for 2 international journals. He was awarded with bronze medal from Infosys through Campus Connect program for 2 years continuously, and silver medal in the year 2016. He also received Best Paper Award in the National Conference at Sri Krishna College in the year 2018. He has chaired and acted as a resource person for many conferences. His area of interest is data mining, fuzzy logic, machine learning, big data, and deep learning. He has total 18 years of teaching experiences. He worked in Sri Vasavi College, Erode around 4 years. Currently, he is a professor in the Department of Information Technology at Vellalar College of Engineering and Technology. We are very much happy to have him for the today's session. I welcome Dr. V. Srinivasan sir to handle the session now. I hand over the session to Dr. Srinivasan sir. Thank you.
Thank you, Mageshwari ma'am. I hope I am audible to you. If you have any problems regarding in viewing my PPT or clearance of my voice, please inform the information through chat box, so that if any problems is there, we will just clarify with that doubts that you're having. Okay. Today's session is taken by me, Dr. V. Srinivasan, professor in IT department. I'm going to handle you. The session is full of, we are going to speak about the big data analytics and tools. So mainly we'll be seeing with the tools. So before going into the tools, I'll just refresh something about the big data analytics. I hope you might already have known what is big data and other things. I just slightly refresh, then we'll go into the tools. What we are going to see, there are different tools that are available for big data analytics. We'll see some of them. Okay, we'll get into the slide now. So why we need to go for big data? So what is the reason that we are going for big data? You know that previously we were using cell phones, so which was about only a keypad, right? We used only keypad for phones, not more than that. So earlier that, before that, we used only landline mobiles. So when we were using landline mobiles, I was just seeing the button in when I was in small age. I was seeing the button. Why this ABCD was given in the numbers? So you can see for number 1, 2, 3, some numbers will be written. If you have seen the old uh, DOT line mobile phone, so you can see that. So that time I was just asking my father, what is all this about the why only we are using only numbers, and why is that we are having ABCD and all that. So that time I was not aware that we are going to have like that, right? So that time phone is very rare. Maybe few houses will be only holding the phones, but nowadays you can see that we are having phones in each of the house, to maximum of the number of persons they are having. Even somebody are using more than 2 or 3. We have some problem. Are you all able to see my screen? Just wait. we'll just share the screen. Someone has reported that the share uh, PPT was not shared properly. Just hold a minute. Enable. It's not enabled. Previous. Now you are not able to see my screen. Yes, right. So this is my first slide. So I was just only speaking some information about the phones, right? Okay. So we can see that we have phones more than even one person may use two or three phones like that we are having. So just think of the data when we were using the keypad phones, right? So what was stored in the keypad phones was nothing but only we stored the contact numbers. We never stored anything other than that. Maybe some messages where we were storing, but after that we don't have stored much of the information, and you can see that it may maybe go around 200 MB. So we just talk about only MBs when we were using keypads, right? But think now you are having a smartphone, so think how much data you are required. So 8 GB, 16 GB, 32 GB. So when I was purchasing a new mobile, right? So I just thought it's enough to have around a 16 GB was more than enough for me, I thought. But after the years are going, I realize that the data what I got for 16 GB is not at all enough for my phone, because you can see that there are a lot of WhatsApp group. When I got the mobile, I just had one or two groups, but now we can see that lot of groups are there. WhatsApp group, lot of groups are there. Then you can think, right? Even if you are if you are a student, you know that even for one class we don't maintain one WhatsApp group, right? So your close friends, then the entire class, then girls separately, boys separately, and very close friends, family friends, right? So like that you can see lot of WhatsApp group, right? So what we are sending is something not text alone. We send photos, we send videos, we forward the information. So lot of information are sharing around the phones, right? So just see from a keypad, right? 50 GB was more than enough that time, but now we are not even able to cope up with 16 GB is not enough for me. I'm just for every month I just go to into WhatsApp and delete all the images and videos. So only then I get the memory free space. If not, it is going to be it will be full, and it will have no space to engage. So how these volumes are growing, you can see. So now it is like this, then in coming years it will be something it's going to be different. So from 2009 to 2020 we can see that the data has been growing very fast. So you can see this diagram, right? A dot was there in the around 2009, but now you can see a big circle that the data has been very largely increased, right? So that is how the data are growing bigger and bigger everywhere. So this is just increasing like set zettabyte to 35 zettabytes and so on. So from 0.8 zettabyte to 35 zettabytes we are having now, right? So it is only going to increase, it is not going to decrease, I think, because we take more photos, videos, and it is continuously increasing, it is not decreasing. So that is why nowadays we speak about all about the big data. So how this big data is going is, it is just increasing, like not double or triple, it is going like 40 times more, right? So it is something going fast, very going information. So you can see that even the same videos is being posted in different groups. So you can see in your WhatsApp itself that lot of same videos will be repeated again and again from the different groups, right? So you store a lot of things, right? Okay. So in earlier database, so we were having only like relational database. So we were using like Access, SQL, and something like that. And we can see that we need a relational database to have connection between two different databases. So only when you have a connection, so when you have a relation between the two table, then you will be able to retrieve some information from other. So for that you need to know how it has to be done and so on. So it was very difficult for peoples to handle this big data. So nowadays we can see that the big data is a digital economy and society. So it is continuously growing. So billions of GDP by 2020, and factors about labor and capital informations. So on data science fourth paradigm. So you can see that it is continuously growing, right? So it is not going to decrease anymore, and it is continuously growing. So where this data all comes from, right? So how it is being generated more. So we did not use the internet earlier, but nowadays what we are using is full of internet. So whatever you want to share, you share through the internet, you share the information. So that is how it is being done. So we can see that there's a change in our lives, right? So now you can see that. So when we 1 year 2 years back, if we have some webinars, so we just go to some colleges or some places so that the fixed seminars or workshops will be conducted, we will attend and will come back. But now today what happens is, it has become digitalized. So we use it in some other place, and I am sitting in some other place, we speak now, and you are able to hear what things are. So you can analyze that. So during in the live session, you can see that there is nothing is going to be stored. So I speak it, you just get the information, and that's the end of the session. We'll provide you with the certificates and we'll go off. But now what happens is, so I speak, it is being recorded, and how many peoples are coming in. So this will be posted again into the YouTube, so that the entire world is getting the information about what we are speaking, and in what session we were speaking about this. So all things. So what happens is, my data is going to go out, like for 1 GB it may be we maybe just put this video in the YouTube, right? So so what happens is, the data are getting increased in the internet. So changes in our life, and data are getting increased. So it is difficult for making a decision. So for example, if we have one thing, for example, if you have one college in your place, then you will have a decision, okay, we'll study in this college. Or if you have some specific college, you can have some specifically, okay, this college I want to study. But what happens now is, once they complete 12th standard, so they automatically go and search in the net. So if you want to go to Coimbatore, or you want to go to Chennai, you just list out all the colleges in Chennai or Coimbatore, and you can just select which one you want. So there are a lot of criterias are given, right? So whether it is an NBA aggregated, or NAC oriented, and so on, right? So you can see that whether it is NI, it is having an NI or a frank. All these things is seen in the internet, and you make decision, okay, this is the good college based on the ranking and other things, right? So this is how the big data is having the information every day, and every seconds the data are getting increased. So right, it's the decision making complexity. right? So it is very difficult to make a decision when you have large information. So you have to go into a specific information, and then only we have to finalize, right? So that is how this big data is working. So maximum when we search for a particular information, so we can see that unrelated informations are coming up. So for example, if you're going to search for something like you're going to buy some cell phone and you want to search in the Google that what cell phones are being displayed, and you want to see that, then you can see that not even the information about the cell phone, but it will also have the information, other things like pouches and charger, all other information will be also given, right? So that is the digital era, that they want to just give you something more than what you are expecting here. Then we can see that an area of applications, right? So area of applications that the big data is utilizing is, that it is in health and wealth and policy making. Smart cities are using this. Then education oriented, like creating different workshops and other things, like we have some online educations like MOOC and Udemy and so on, right? And we also use robotics about human robot interactions. So all these things on in all areas, I can say. So when you go to a shop, right, when you just purchase something, then immediately they ask for your name, phone number, then which date you were born, all those things they try to collect the information. So that is how they gather information. And when they give some discounts, then they pass the information through the mobile phones and so on. So and moreover, it is being mainly used in research activities nowadays. So that is the power of the big data we have. So here in this slide, I just want to explain how the traditional analytics versus big data analytics, right? So traditional analytics, we use just descriptive analysis and diagnosis analytics, and whereas in big data, so you predict what is going to happen, and also you just use an data science, right? You use some technologies to predict what is going to happen. In traditional, the data sets are limited. It needs cleans data, and it is simple models. But where in big data, we have large scale of data, so more data types are there. Raw data we have, and then it becomes complex data model. In traditional, the cautions are what happened and why. So what's happening and why it is going to happen. But in here big data, we have correlation about more accurate answer, right? So nowadays we go for an accuracy. We don't just want to say, okay, this many fellows passed. No, not like that. So we want to have an accurate information. So using different technologies, we will be able to provide all these things. So what is the objective of this big data analytics is, so we get information, we get data from different resources like web data, city data, financial data, agriculture, sensor data. So all these data we just get into an one information, and we start extracting this information from different platforms. After extracting, we just integrate them. So which is needed for which one. So you integrate them. Then from after integrating, you compute with the data management. So how you need to store information, all those things you compute with that. Then you go for visualization. So once you have large data, we cannot just look into what it is, what information it. So only when you have a visualization effect, then it is more effective. So for example, if you're going to see some dresses in online cart, so if they just only display the number and the name of the shoe, then it is not going to help in any way, you unless you see the figure out, right? So online shopping, you see that what is the material content, and you see the visual effect of a particular thing you are going to purchase. So this all, so you go for visualization. So where all it is being used is online shopping, you use smart cities, you go for some health tips, then financial information, then if you want to gather some farming information. So all these things can be gathered from internet. So there is nothing that you want to know. If you want to know anything, you just get into the Google or you get into the internet and you just click on it. Automatically you will know what information you exactly wanted. So even for example, if you want to attend a class or you want to know about a C programming, right? It's very easy. Go into the internet, just click on and select the website you want and you can see. So a lot of tutor is also available online, right? So this is how it is has been used in big data. And the main thing is we have is privacy and security. So if you have a problem is the privacy and security. So once if it is good, then there is no problem at all. So always the internet has the policy. So based on the policies only you have to work on it. So mainly this big data nowadays we are using it for the research objectives. So how the data to be used. So you want to analyze the data, compute the data, and you go for privacy and security issues. Then we just project the data that we need. So maximum the four paradigms are, so we use it for bio, chemistry, engineering, and social. So everywhere we use the big data. So wherever the data is more, then we say it is big data. So that is growing. Data are growing. So we can see that in every platform the data are growing, right? So how this big data analytics workflow, right? So you extract, integrate all the data that you have extracted, then you compute to the management. So which data is having the which data. So if it is for farmer, then you put the information in the farmer database. If it is for financial, then you put the information in the financial database. Then you have the visualization effect. So when you want to know what is present about that particular financial information, you can have the visualization effect. Then you can use the applications. So application, we have different applications for each and every part of it. For health, for government oriented, financial, right? So different applications can be used for a different database. And you can, so you gather the information and you present the information accordingly you want it. So the big data is not only a computer oriented data. So it comprises of all things, like agriculture, finance, smart cities, all those things we can be combined into. So the expected outcome from the big data is, that is, we have new methodologies that we are developing, new applications based on the industries, and new digital economies that we are developing. Then educational programs for students. So you can see that lot of webinars, seminars, guest lectures or have been uploaded in the YouTube. So you can just go into the YouTube, and if you want to learn anything about it, that you can just click on it and you can watch whatever the video want. So you want to just sit for 1 hour, or you want to sit for 10 minutes, or you want to listen for 5 minutes. So all these videos can or put it on the website. So based on the timing you can just work and see what you want to know. So when we talk about big data, we mainly speak about the four V's of velocity. So four V's of big data. So that is, one is a volume. So as we told that, when compared to the 10 years before, now we have the bigger volumes. Even you can say that if you're having a laptop, so previously we used to have 100 or 200 GB hard disk, but nowadays we go for uh, what maybe more than 500 GB hard disk and 1 trillion, right? So that is how the data is being continuously growing. So that is the volume. Then you can see the velocity, how fast it is traveling. So the thing that, suppose if you want to send an information from one place to another place, so how fast it is traveling. So if you have a mobile in a remote place, maybe in your house of your tata party's house, if you're staying there in a village, you can see that the videos is going slow, or the mobile is very slow, you are not able to access to the classes. So what happens is you want to come to the city side, so that the more power will be there for transferring information and for the live sessions, so that velocity will be noticed. Then variety, we have different types of data. So earlier we had only, as I told you, that earlier we had only one format, that to store the contact numbers in the phone. But now what we have everything in the phone. You want to store the video, you want to store the photo, image, you want to store the context, you want to work with an Excel, PowerPoint, whatever thing you want to do, it is done. So that is a variety. So we have different format of the data. Then veracity is that what exactly is needed, right? So what exactly is needed, for example, we have some information in one location, and if you are going to share that information in another location also, you should have the same thing, right? So the best thing I can show is that if two persons are sitting nearby, you can see the classes going on. So one video, the video will be going on, and another video after that only the data will be projected, right? So you can see that there is a some delay in that, so the information can be, so that is the veracity we are speaking of. So coming to our part of the tools, big data technology tools, so we have a lot of tools that are being used in the big data, like Hadoop, Vertica, MapReduce, KDB, Greenplum, ETL, Hive, MATLAB, or Revolution, R programming, SAS, right? So lot of big data tools are available. So each company uses their own tools. Sometimes they use their own tools, sometimes they go for an open tools. So whatever the tools that are being provided for a big data is an open source tool. So maximum you can see that all so just I have listed only 15 big data tools from the top, so that there are a lot of tools that are available in the online open source. I can so some are listed here, like plenty, Apache, Hadoop, CDH, Cassandra, Nim, Data Wrapper, MongoDB. So I'm not just going to go in through all these tools, because we will have no time for that. I'll just give an just about some of the tools, what how they are using and other things. Then we'll see with one tool how it is being used, and we'll see about Hadoop, how Hadoop concepts are being worked and so on. Right. So we'll get into each tools how they are using. So one is in Plenty. So Explainty is an analytical on the cloud, right? So we this Explainty was designed for using it in the cloud storage, so that it supports different formats, and graphical things were being used. Then this also it is a completely toolkit, that either you can use the coding concept, or you need not use the code, depends upon the person. So if you want, they want to only use the menu and other things, they can directly use. So and also if you want to support with the code, that is also being provided with the Explainty. So this is a solution for marketing, sales, and support and other developers. It has been used. So Explainty is also you need not invest more on this tool, so that you can just have a open source tools and you can use it. So Explainty, you have an advantages and disadvantages. One is the connectivity to variety of data. So you can use any type of data. Variety of data can be supported by Explainty. And so since it is providing with different complex varieties of data, so definitely we will have some complex data preparation and other things. Um, Whereas on disadvantages concerned, we have an annual billing option is available for this tool. So when we come for pricing, so normally all these tools will be provided as an open source tool in the web, right? You can just download it and you can start using it directly. Whereas you will have only support to some features, it will not give you the over full features of it. So for education oriented, they just give this for some support, that how to use on it and other things. But when you go for commercial thing, then you need to uh, pay for something, right? So in Xplenty, they just give the billing system based on the annual, so maybe some minor. So for all these tools, for education purpose, we have free open source. But whereas when you need to use it for commercial purpose, then definitely you have to pay something for to use the extent features of it, right? So some features will not be available in the open source tools. So that is the problem with all open source tools, right? The next tool that we are going to see is about an Apache Hadoop. So in Apache Hadoop is a framework employed cluster files, so that the data are stored in a different features in clusters. And this is an open source framework that it is written in Java, so that you can go for cross platforming support is provided. We can see that more than 50 companies are using Hadoop, like web services, Amazon, IBM, Microsoft, and so on. Then we can see about the advantages is that, so we this uses in Hadoop distributed file system. So it has its own file systems to store the information and other purpose, and this is mainly used for the research R&D purposes only. Some problems with this Hadoop, Apache Hadoop is that disk-based issues, right? It does not give provide you more space for user, right? So another other thing is in pricing. Okay. The next concept is cloud era distribution for Hadoop. Right? So cloud era distribution for Hadoop. So this is another tool. So this we will use it for an enterprises classes, that is we use for mainly for business oriented peoples, right? So maximum business oriented peoples use this. And we have free platform distribution, so it can be used in any platform, and I can use this tool. This tool also supports like Apache Hadoop, Apache Sparker, Apache Impala, and many other tool of the Hadoop. So this is CDHA is an part of the Hadoop tool. So where all these concepts are implemented with the CDH. Then this is an administrative manager too, so that you can manage yourself, so how you want to store the information and other thing. So advantages is that you have the manager administration, so that you can adopt yourself, so how much data you want to have, and how much security you want to have. All these things can be done based on your administration itself. So one thing is this disadvantage is that it is UI future, like chart on, you can use the charts, right? So CM services provided, and you have some problem with sound confusing, right? So this features are not good for that. It is sound confusing, and UI is not more supported frequently. So pricing is same, so it's free for education purpose. And when you go for customer oriented, or you go for business, then you have to pay for some money. The next is then Cassandra. So Cassandra is another tool for big data, where you use NoSQL database. So you might have heard about the SQL database. So it is a structured query language database, whereas NoSQL means, so you need not use the SQL. So that is the main concept, is that here when you use SQL, so it is the concept that you need to have a relational database for connecting to different database and tables. Whereas when you use NoSQL, you need not use relational database. You can directly access to particular database. So that is what we call it as a NoSQL. So NoSQL means you don't use relational operations and all. You can directly have access to database that you want to have. So we have an high profile who are using this Cassandra, like peoples like Honeywell, Yahoo, Facebook, American Express. All these peoples are using this Cassandra. When we go for pros, it is no signal point of failure, so we don't have failure at all. So whatever thing it needs to be retrieved, that will do it quickly, even if it is having massive data, it is automatically replicated. So cons is that we have some problem in troubleshooting. So if you have maximum, you will have no problems at all. But when you come up with some problem, then it is difficult to go for troubleshooting and other things. So as with that, pricing is free, but when you go for commercial, we have to pay something. So next is NIMI. So NIMI is a constant information miner, so that this NIMI is used in the CRM. So that is in the customer relationship management. We use this. So wherever you are using CRM concepts, we use this NIMI tool, so that you can extract some data based on the different concepts for the business intelligence. So this supports Linux, OS, and Windows operating system, so that you can use it in any platform. You can use this NIMIS tools. This also is good alternative to SAS. So we have another tool called SAS. When compared to SAS, NIMI does the better work than the SAS. So the process is that, so it is simple ETL operation. So and we have an integrated very well within technology and languages, and it mostly it is an automation of lot of manual works. We don't use we just give some commands, and we just sit and watch how it is working, right? And then NIMI, we have a problem with this, that it occupies more RAM spaces, so it gets delayed because of that. So graphical database cannot be used effectively in NIMI. So next tool is that we have a data wrapper. Yeah, data wrapper is an open source platform used for visualization effect, right? So whatever we have the information in a database, so we would like to just have some information. So it is not so easy to just make a query and get the information. That's very difficult. But whereas in data wrapper, you can just have a visual effect. So whatever the steps or whatever the commands you want to give, it can be given very easily through the menus, and you can get the information very quickly. And if you want to have a view of the data, so just instead of selling this this company is rising up and this company is going down, you can just put a broad chart and show which company is top. So that will be very easier when compared to other things. So like some companies like using Fortune, Jones, Bloomberg, Twitter, all these peoples are using Twitter, all this are using data wrappers, right? So each tool is different from each other tool, because you can see that one concept may not be supporting to one another concept. So that is why we just some people combinedly use these tools. Some use data wrapper as well as the Hadoop concept. So all this they just mingle with other tools also for their best performance. When you go for advantages, it is well for a type of all devices. So it devices, it can support mobile, tablet, and desktop operations, and laptop, all those things it can support in all devices. It will work very good, right? So you require no coding at all for this data wrapper, because everything is visualized and menu oriented. So you can just click on it and you can have any information you would like to have. So the limited problem with this is color palette. So they don't provide it with more colors. They just only support with some colors. That's the thing. So next is the MongoDB. So in MongoDB, I just thought that I can explain this some part of it, how it is working and other things, right? So how the database is created and other process it is going. So in MongoDB, you can see that it is not using NoSQL, right? So it is not using the relational database, and it supports with a NoSQL document oriented databases. This is written in different language like C, C++, JavaScripts. All this coding can be implemented in the MongoDB. This supports with different operating systems also, so Linux, Solaris, and other things. The MongoDB, we have one benefit is that we can work with the aggregation and ad hoc queries, right? We can work with an aggregations and that is to combine with different database, and you can have information what you would like to have. Then this is also a server-side execution program using JavaScripts. MongoDB supports all these things, so it is management oriented also. Some of the main features of MongoDB users are like Facebook, eBay, MetLife, Google, etc. So MongoDB is easy to learn, and it supports multiple technologies, and different platforms are being used. When you have disadvantages, you have a limited analytics and slow for certain use cases. So MongoDB also is free but when you go for commercial oriented, you have to pay for something. Right. I told you that we will. I will explain little more about MongoDB. So one thing is given that MongoDB installation. Here you have the YouTube thing. So just to type in installation of MongoDB in your Google, you will have different videos from step by step. They have just shown how to just download it from the video. So you can go to the Google and just type MongoDB installation, and automatically you can download that, and that will be sitting in your place where C programming files MongoDB server 4.2. So 4.2 only will be able to download. So you can download that, and that will be seated in the location program files MongoDB server and 4.2. So you can navigate step by step process is given in the video, and you can just download it and install in your system. Then you can use that, right? It is like the only one thing you have to do is you have to connect with the MongoDB. So you have the command prompt. So you're going to just work out in the you are going to work out in the command prompt. Before going into the command prompt, you should know that whether the MongoDB and the database are connected together. So only when the MongoDB is connected with the database, you can use this MongoDB, right? So for that, you have to type the command mango.exe, so that the prompt will tell you whether this has been linked with the database or not, right? So you can just go to the website, download the MongoDB installation part. You can install it. Then once it is stored in your file, you have to set the path. So that also they have shown in the video how you have to set the path and other things, right? So once it is set like C colon the program files MongoDB server 4.2, then automatically when you type mango.exe, then it will say that whether the database is connected or not. So once the database is connected, then it's more or like using SQL commands, right? So in SQL commands, you know that we create, read, update, and delete operation. All these things we perform, but we use a relational operation there. But in MongoDB, you don't use the relations at all, right? You need not have relation between different tables to get the information. You can directly link to two different table, and you can get the information whatever would like to have. So we are going to just see how MongoDB is going to work out for the create, read, update, and delete operations in MongoDB. So to create a database in the MongoDB, so this is the command prompt you will have in that command prompt, right? So db dot create collection students. So when you say db, it is a database, creating database dot create collection is the command, create collection is a command. So you say the name, what name you are going to create. So this is, we are going to create the name students, right? Student is the name we are going to. So what happened is it will give the information whether database has been created. So it says that okay, one database has been created, one student database has been created. So it gives the information whether it is done or not. So immediately it will show. So this is how you create one student database. Then in inserting commands, so once the database is created, then you need to insert the records, different records you need to insert. So it is done with a command prompt. db.students is the name of the database. Dot insert, that means you're going to insert some record into that. So you open the bracket, within the flower bracket you mention what are the thing you're going to add. So say id1, so id1, that is identification number. Then student name, you're creating Michael. Then grade is 8 standard. Is hobbies, is internet surfing. So this is how one database is created. So once you type all these things, then you can see that that gives an output right result inserted one record. So you can see that one record has been inserted, so that gives the output also side by side. Then you're going to insert the second record with the name Matthew, then third record with the Aryan, and fourth record with the Harish. Right, so 4 records has been inserted into the record students. Then you're going for read command, so you're going to read what all present in the database, right? So for that, db dot student dot find. So when you say find, it finds all the database that are present in the particular database, right? So here we have also a command called pretty. So when you say pretty, it displays the information line by line. If you don't say pretty, then it continuously prints all the data that is present. So that is the difference. So here we can see that we have inserted 4 database, 4 records. So db.student find, it lists all the 4 records. So for the space consumption, I have just only listed 3 tables that are present already. So this is to just list the records that are present in the database. Then you go for inserting the command, inserting the record, new record you want to insert. That is, you want to update the information, so that can also be done. So either you insert or you update. So here we are going to update one particular record with change of hobbies, right? So previously you can see that Aryan David was having the hobbies as skating. Now we are going to change these hobbies as chess. Okay, you can see that. So db.student.update id3, right? So identity record 3 with the name Aryan David, grade 8. You're setting hobbies to be changed, right? So you're setting hobbies to be changed as chess. So there you had a skating. Now he is going to have as a chess. You're going to update, right? So that is the command here, upset true, right? So then automatically it updates the information. You can see the result given by the tool. Right result, n is matched, that is the rn is matched with 1, right? And updated is modified is 1, right? So it also lists how many matches are there in the particular table. So based on that, so how many tables are, how many records has been modified. So all these things will be displayed as the output also. But whereas in structured query, we cannot see this line. In structured query, if you say it is insert, it is inserted, that's all. So only you have to list out and see. But here in MongoDB, it lists out what things are present, right? So what has been changed, how many records has been changed, all those things will be set clearly. The next step is read only particular files. Suppose if you want to read on a particular file, so some tables, like you want to mention that name and list only that name, or you mention that the id number, only that id number to be displayed. So that is here done. Read only a particular file. So database dot student find id of 5. So if id of 5 is there, that will be listed. So you can see that there is no dot pretty, so that it is listed continuously. If it is dot pretty, it will be listed line by line. Next command is read all names. So you're going to read all names that are present in the table. So you just give the command db dot student dot find student name id dot 0. So if you specifically give 1, 2 or 3 or 5 like previous one, it will list only the 5, right, fifth record. But here, if since we have given 0, then it has listed all the names that are present in the particular database. Then this also uses in relational operator. Different relational operators also use. So I have just listed one or two. We can see that db.student.find grade, right? So find grade equal to 8. So you find the records. If you have thousands of record, so what are the grade, whoever is having the grade 8, that all will be listed, right? So that all will be listed here, grade equal to 8. So it will be listed. So I have not shown the output here, just through the command alone I have just put it, right? Then not equal to, so that means it is not equal to baseball. For example, db.student find hobbies, right, not equal to baseball. So that is other than baseball, you can list all other peoples in the record, in the database, from the all other records that will be in the from the database. So leaving this baseball, it will list all other things. So next is e- either chess or skating. So we are combining two information. So here we have told that no baseball, other than that all will be listed. Here we are saying that chess or skating. So if the student is playing chess or the student is playing skating, all those things need to be listed. So for this command, you use db.student.find hobbies in. So hobbies in chess and skating, both will be considered, and it will list all the records that whoever is having the hobbies chess and the skating. Okay. Okay, next is the delete operation. So delete, you just need to delete the database, right? So db.student.remove, right? db.student.remove id. So you want to particularly delete one record, that is the name having id equal to 4. Then this will be the command. So db.student.remove id is equal to 4. Then right, so it gives the result that one is removed. If nothing is removed, then it will say that there is zero is removed. Okay, suppose we want to delete the entire database that we have created, that is student, then you can see the command that db.student.remove all, that is the open brace and close brace, right? So db.student.remove, then it will deletes all the record that are present in the database. So the result that is given by that tool is that it has removed 4 record from the particular database. So this is how if you want to delete a particular file, or if you want to delete a particular entire record, you can do it. So this is how the MongoDBs are working. So the MongoDB is working based on the query, right? But in relational database, in structured query SQL, you have a relational database, whereas in MongoDB, you don't need to have a relational database. So that is the only difference we have between MongoDB and the SQL. SQL will follow the relational database, whereas in Mongo there is no need for relation at all. You can just directly do whatever you like to do. So that is the difference between Mongo and the SQL, right? So this is one tool I want to just clearly show how it is being worked. Then another tool is that we have been speaking about Hadoop concept, right? So Hadoop. I'm not just going into the program, how the Hadoop is going to work and all. I'll just totally explain how, what is the concept that is being used in the Hadoop, right? We also have some programs regarding how to count a word. So this is the concept I'm going to explain. A program telling how to count a word from a database, right? If you have one document, so what are the documents is there, you want to count how many numbers of these words are present, then automatically that Hadoop can do it for you, right? So that's this is how used for like Google, Twitter and other things. So they all use this concept. So we say that this fellow is saying something about this, then you just list out who all are speaking about this particular concept. For example, if you say that they are regarding COVID, who all spoke about today in a different websites, then what happens is you search all the website, the tool will search all the website whoever spoke on COVID, right? If you say some people like some Virat Kohli is going away from cricket, okay, so you want to put that word and search in all the website whoever has commented about Virat Kohli for his cricket winding up, that all things will be collected and given as an information for you. So that is how the Hadoop concept is working. So they have the program called word count. So we have the program called word count. I am not going to explain the entire program here, but I will explain what is the concept that we are going to use it here, right? So you can see that the Hadoop concept, you have an input files, right? So input files is that what is your word to be counted. So for example, first input is apple, orange, mango, then orange, grapes, plum. Here apple, plum, mango, apple, apple, plum. So this is the what we can say, we can see it is in one document or a database. We can say it is in one document, here is an another document. So you're inputting this document and this document into the Hadoop. Here we can see that, so it separates how many apples are there, how many oranges are there, how many mangoes are there, right? It divides, right, into three, like, so here apple, orange, mango, orange, grape and plum, right? So in first one we have an apple, orange, mango. Here we have a orange, grape and plum. So it divides that two line into a different files, input files. Then from this single file it counts how many apples are there, how many oranges are there, how many mangoes are there, because only we have three words here, right? These three words, apple, orange and mango, right? In another file, so this is the input file. From this input file we have divided into two different files, right? From two different files we have started counting. So here we have orange, here we have grapes, here we have plum. So we count how many oranges are there, how many grapes are there, how many plums are there. So each one has the one, right? So in the same way it goes for the another input file, right? It divides that file into two, right? Here it finds how many apples, how many plum, how many mango. Here it also finds apple, apple 1, plum 2, right? So it counts how many apples are there, how many plums are there, right? Individually it counts. So you can see here apple, apple, so apple is 1, apple is 1. So you can see that two apples are here, right? So from this key splitting, right, from this key splitting you combined apples, grapes, mangoes, oranges and plum, right? So from this key database you split how many apples are here, how many grapes are there, how many mangoes, how many oranges, taking from all these things, taking from all these files, right? So if you say apple, so one apple from here, here we don't have any apple, here we have one apple, so one apple from here, here we have two apples, so two apple from here. So totally we have four apples, right? Likewise you find grapes, so here no grapes, here one grapes, here no grapes, here no grapes. So you find the mango, one mango from here and another mango from here, so two mangoes. Then oranges, same way, plum, same way, right? So after getting this, you get it as a aggregation, right, into one single apple. So from this you count how many apples are there: apple 4, grape 1, mango 2, orange 2, plum 3. So you convert how many apples are there, oranges are there. Then finally you give the output: apple 4, grape 1, mango 2, orange 2, plum 2, plum 3, right? So but when you see this this looks very simple. What if we can count it here: apple 1, apple 2, apple 3, apple 4, that's the end, right? But just think of the database when you have more than 1,000 pages. This we, for explanation concept, we have just given only 2 lines, right? But just think, when you search for something from 1,000 files, then it becomes more concept oriented. So this is how this Hadoop tools helps you to find the results. So this is one concept we have discussed how the Hadoop is working on a counting a number of words in the program, right? I think we have 10 more minutes to go. Yes, okay, we'll try to finish quicker. I think only 2 more slides to go. Fine. So that was in Hadoop concept I was speaking. That is in one tool that we are using. Then another tool we are using is in R programming. So in R programming, you can see that many peoples who are using research. So maybe your teachers, after completing their PG, so they might have been just applied for a PhD. So in PhD concepts, all maximum of the people, they use R Studio. So what is in R is that so they have already written some algorithms already present in the R tool. So you can just select one tool for I don't know how many of you know about what is classification, support vector mission, clustering, all these concepts. So this all different concepts that you might have learned: what is cloud, what is classification, what is clustering, regression, right, data mining, all this all comes under the data mining, right? So for each thing, for classify, if you say about classification, so how you classify things, for that they have different algorithms like support vector mission. They use neighborhood clustering. They use different concepts, different logic they are using for programming, right? For classification itself, we have more than 10 15 algorithms are present. So think of like that. So for classification one, for regression you may have 15 algorithms. For another process, data mining, you may have a 50 of algorithms, right? So this becomes very difficult for each person to just design the algorithm and then go for implement. So what this R programming has done is that it makes you more simple to create algorithm. So which it has already inbuilt some algorithms for classification and all. It has some already built-in algorithms are being provided, so that the researchers can make use of that and give the database information, and they can get the data about data output, as well as they can also have the graphical representations. So you can see here that this is an R programming platform, where here you start typing your code. Sorry, here you can start typing the code. So as you use in like C, JavaScripts, all these things, you can here also you can just plot, right? So you use the library ggb lot.2, right? So that is library functions that you're going to use for presenting the graphical representation of your database, right? So you can see that your this program has just shown you how to create one particular picture, right? Particular picture you want to create. So you can summarize as this is a diamond shape. You can see that this graphical representation shows a diamond shape, right? I can view, so you summarize it as a diamond, right? So you can also set the prices for each diamond. So if it is red, this is the price, and all these things you can set it, and you can find the average mean of a diamonds, right? So what is the average you have, and you can have the clarity of the diamonds, painting water, painting what you want to do, right? So that you can see, you can see that plotting how you want to plot. So qp plot, so q plot, right? Caret price, you're just listing out the price, right? So this is the price you're going to specify. And data, diamonds, so data should be represented in diamond color, it should be clarity. So you have an x-axis and an y-axis. In x-axis you have a caret, and y-axis you have a price and main diamond prices. So you can see that from the database it has created a database, sorry, graphical representation. So from database it has shown you what it is being. So this is the in what actually in the database is that it has shown that this informations have been listed in the database. From this x and y axis, this automatically generates the graph based on the commands that we have given here, the coding you have done here, no? So based on that, this will be given. So you can in a single window you can have the coding process. You can set what are the which one is an x-axis and y-axis, you can specify. So you can see the output graphics. So here is what database has been connected with this. From based on that you get the thing, right? So this is an R programming concept. So each tool is designed for different concepts. So one might be for graphical, one might be for having counting of data, so one might be for used for internet oriented, one tool might be used for cloud computing, one tool may be used for clustering, right? So like different tools has been designed. So it is up to you what is your need, what is your research work, so what you need to do. So based on that you can select the particular tools and you can work on it. So yeah, I think it's all almost time, and I will just want to conclude also. So I thank you very much for having provide me a session to have an interaction with you for 1 hour. I thank the management, principal, and all other teams of Department of IT who have given me a nice opportunity to interact with you all. Thank you. So if you have any doubts, please share your doubts with the chat. If possible, I will just give you an intro what you are expecting or not. Thank you. Thank you so much for patient listening. Thank you all.
Srinivasan sir, thank you very much for your informative session. Participant, now we can end our meeting. Tomorrow we will see on the first session. Today, 3 will be related to your database concepts. So we will see tomorrow. Thank you. Thank you, one and all.